Okay, number 2. A car and a motorcycle, this is from the last of the acceleration and free fall questions. A car and a motorcycle start from rest on the same track at the same time on a straight track, but the motorcycle is 25 meters behind. Okay, so this distance is 25 meters. The motorcycle accelerates at a uniform rate of 4.4, so starts from rest, VI is 0, and it says the motorcycle accelerates 4.4 meters per second squared. The car also starts from rest, so VI is 0. The car accelerates at a uniform rate of 3.7 meters per second squared. How much time elapses before the motorcycle overtakes the car? Okay, so we don't know how much time is going to pass, but however much time it takes the motorcycle to catch up to the car, that's how much time the car has to move. So after some time, the car will have moved some distance, delta d of the car, and the motorcycle will have moved this distance, which will be delta d of the motorcycle. We don't know what either of them are, but we know that delta d of the motorcycle, looking at our picture, has to be equal to delta d of the car plus 25 meters. So we're going to do exactly like what we did in this one, in the number 1. We're going to get an equation for our delta d of the motorcycle. It's going to be equal to VI delta t plus 1/2 a of the motorcycle delta t squared, and the VI of the motorcycle goes to 0. So delta d of the motorcycle is equal to 1/2 a delta t squared motorcycle. Problem is we can't find this because we don't know delta d of the motorcycle and we don't know the a of the motorcycle. So now we have to come over here and do the same thing for the car. It'll be VI delta t plus 1/2 a of the car delta t squared. The VI delta t is 0, so it'll be delta d of the car is equal to 1/2 a of the car delta t squared. Again, we cannot find it. We don't know delta d of the car or delta t. So again, we have 3 unknowns: delta d of the motorcycle, the time, and delta d of the car. It means we need 3 equations, and lo and behold, we have them. Okay, so now where delta d of the motorcycle is, fill in 1/2 a of the motorcycle delta t squared. And where delta d of the car is, fill in 1/2 a of the car delta t squared, and keep your plus 25. Now we have 1 equation, 1 unknown, delta t. Get the 2 terms with delta t to the same side. Actually, if you want, first multiply by 2. You don't have to, but I'm going to do it because I know fractions screw some of you up. But remember, when you multiply by 2, you also have to multiply the 25 by 2, so it becomes 50. Now get both terms with delta t to the same side. So since this is added to the 50, subtract it. So a of the motorcycle t squared minus a of the car t squared is equal to 50 meters. And now we're going to use exactly the same trick that we used in number 1. We're going to pull the t squared out. And we'll be left with a of the motorcycle minus, and in this term, a of the car is equal to 50 meters. And now divide both sides by the bracket. So you'll be left with t squared is equal to 50 meters over a of the motorcycle minus a of the car. And now fill in your numbers. A of the motorcycle was 4.4 meters per second squared. A of the car was 3.7 meters per second squared. So this becomes 50 meters over 0.7 meters per second squared. So you'll end up getting a t squared of 50 divided by 0.7. That's 500 divided by 7. So it's 71.42857, and then I think it repeats. Second squared, take the square root, and you should get a t of 8.4515 seconds. Okay? That's the first part of the question. Second part of the question says, how far will each travel? So now we go back up here and fill in this in. So delta D of the motorcycle will be equal to 1/2. A was 4.4 meters per second squared, and the time is 8.45, etc. squared. I'm not writing all the digits because I don't have enough room, but I promise I'm keeping them all in my calculator. So square it and multiply by 2.2, and you should get 157.143 meters for the motorcycle. Then go over to the other side and do exactly the same thing for the car. So 1/2, 3.7 meters per second squared times 8.4515 seconds squared. Again, try to keep all your digits if you can. Square it, multiply by 1/2 of 3.7, and you should get 132.143 meters. Now, you might notice these two distances are not the same. The good news is they're not supposed to be the same. One is supposed to be 25 meters bigger than the other. If you add 25 meters to the car, you should get the motorcycle, and you do, right? 32 plus 25 is going to be 57. And if you haven't rounded your decimals too much, they should work out to be perfect, like spot on. Okay, so that's part B. Part C says, how far ahead of the car will the motorcycle be 2 seconds later? So 2 seconds later, that means delta T will now be 10.4515 seconds. And how far ahead? So you need to now go and find out how far did the motorcycle travel in this time. So 1/2, 4.4 meters per second squared times 10.4515 seconds squared. Delta D of the motorcycle equals, so I need to add 2 to that, square it times 2.2, and you get 240.3164 meters. So this is part C. And now you need to do the same. So this is the motorcycle. So now you need to do the same thing for the car. So it was 1/2, 3.7 meters per second squared, 10.4515 seconds squared. Delta D of the car equals, so whoops, I need to put my time back in, add 2 seconds to it, square it, times 1/2 of 3.7, and you get 202.084272 meters. Okay, so this is how far the car has traveled from the beginning. So if you find the difference here, the difference in these two is actually 38.2322 meters. But that's not really how far the motorcycle is ahead, even though it looks like that on my sheet, because the motorcycle started 25 meters behind. So you actually have to take the 25 meters off, and you would get 13.2322 meters. This is how far the motorcycle is actually ahead. Okay, so that's number 2 completed. Very good.